Alrighty, so I was hoping to be able to go over the quiz too, but I don't see the key up, so I don't want to have someone see it that didn't take the quiz. So I'm gonna go ahead and move with chapter 4. Let me give myself some more space. So we have this vector problem. There's 3 forces that act on a body, and we're asking for a 4th force to keep the body in equilibrium. So because it says in equilibrium, we know that that means that the total value of the forces has to be 0, right? Because if there's equilibrium is kind of like there's no net force acting on it. I used to also think of it as there's no acceleration going on, right? So either way, we're looking for what's the vector that's going to make all of these equal to 0 when you add them all up. Cool. So let's see if I can get rid of that chapter. So we're first going to take the vector components, right? We kind of already know how to do that. The way that she's been having you guys do it in class is just like it goes from here to here. So then that's, sorry, goes from here to here, which is kind of like this 90 degrees minus this 35, right? Because it's here, this total square is 90 degrees. So I'm going to do 90 degrees minus this angle, which is coming into that square, 35. 30. And that's going to give you your angle. And then say for the other one, she'll have you go, that's the angle, that's 290 degrees plus this. So that's going to be 90 plus 90, which is 180, but I'll just write it as 2 times 90. Plus that 25 degrees. Right, so you're just going based on your reference line. So if this reference line, the angles that you're trying to find is coming into the 90 degrees that you're doing it reference to, it's gonna subtract. If it's going out of, you would add. Another way to do the same one would be add another 90 here. So then that's 3 90s. And then you would subtract the 25. Just for checking that it's the same value, I'll plug it in. So this one equals to 245 degrees, right? Then the top one is 250. Nope. Nope. So this one's 205, not 250. And also this shouldn't be minus 25. It should be minus this angle because you're going that way now. So this is your reference line. So that's minus 25 out of 90, which would be 90 minus 25. That gives you the difference between those two. And then that's going to be, so 65. And then you do 3 times 90 minus 65. And then, yeah, that gives you 205. Oh, hey, Samantha.
Hello, Dee. How are you?
I was just doing a vector problem. This is how she would how she tells you guys to add the vectors or like find the angle for the vectors. I can redo that, and it's also on the recording.
Okay.
So the basic idea is what she has you guys do is you start from this line here, and then you go all the way whatever this number is. So then if it goes this way, then it's this angle plus this angle plus this angle, which is that 2 times 90 plus 25. That's the easiest way to do it. And I was just showing that like you could also go all the way from this reference, but then you would do 90 minus 25 to find that angle. And this angle. And then you would do 390. Okay. And then you would do 3 times 90 minus your theta. And that'll give you the same answer as this 205, but this one's faster. And honestly, I prefer just using the angle that is there and just knowing that it's going to be positive or negative depending on how you are, which is what I'm going to do right now. All right, so for this one, we have, let me click focus. This angle here, you have this going in the positive direction, and then you have this going in the positive direction, right? So then that's, all right, up here. Positive here, positive here. For this angle, I have this going in the negative direction. Then this one goes in the negative direction too, right? Because for this grid, it's like up is positive, this way is positive. It's just the normal one that we usually use. And then for this one, we have down, so that's negative. And we have sideways, so that's positive. And then from there, you can start figuring out through your vectors. Let me start doing it over here. Sorry, A. This. This is your X, positive X. And then you have your positive Y. There's an A, not a delta. Using SOHCAHTOA. Type that in over here. Which means sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Here, your opposite is on the X. So that means that this one is going to be, oh, let me change from X. That's going to be using so opposite. Sine equal to X, where this is your hypotenuse. I'm just gonna use hypotenuse because we don't have a variable for it anyway. And then this one is going to be your cosine because it's adjacent to the angle here. And then because we already determined that they're both positive, you're just gonna put a little positive in front of the sine, in front of the cosine. Right? So that means for A, if you multiply the hypotenuse on both sides, where the hypotenuse is the vector force, I'm just gonna put two parentheses for the angle. Oh, I can put the angle in there. 35 positive HA 35 is equal to X. And we can solve for that after I type in the Y as well. Positive H cosine 35, which is your theta. Is Y. And then H is your vector, so that's 30 newtons. So then if you plug those in, you will get 30 sine 17.2 newtons and 24.6 newtons. Cool. So then that's your A. And now we move on to the next vector. No, keep it in orange. Sorry, the controls for the Zoom sometimes. So then for the next vector, it looks like this. I'll put the letter. So then you're having a negative y, or y is in the negative direction, and x is in the negative direction. I guess I should draw the angles too, because that matters. Or sorry, the little arrows. Because this is the x going this way, which is in the negative direction, but you could very well go the opposite way if you had a different vector. Because this vector is going down this way. And I'll draw it in for them. So then again, using SOHCAHTOA, this time your x is the adjacent one. So you're using negative cosine is equal to x. You could technically put this negative with the x instead of the cosine. I just think this way is neater. So that means your y is going to be your sine because that's on the opposite end of your angle. And then if we plug that in, you're gonna get negative h cosine your angle 25. And then negative h sine angle 25. Then I'll plug that in right now. Forty cosine 25. The actual h cosine is positive, but because you know that it's in the negative direction, you're gonna put a negative there. So that's why I'm putting these in parentheses, so you know that you're adding the negative. And sine. Cool. And then, let me see if I can put this somewhere that it's not gonna disappear in text. It's about there. And then we move on to C. Vector's going down this way. So that means this one must be going this way because you're doing it tail to tip. And then this one's going to go down that way. And this one is positive x. So it's negative y. And this is your thing. And theta right there. X is again adjacent to this angle. So that's going to be cosine again. I'm just going to write cosine. Nope. I think I have enough room for this. You multiply both sides by hypotenuse. That's what I've been doing the entire time. I just haven't been writing it. And you multiply this side by h2. Because what you do with one side, you have to do the other. And that's what gives you x. Then your y is sine because it's the opposite angle or opposite side from the angle. This one's gonna be negative, so you write that negative. And this is what I'll write it with the y. You could also write it with the y here and then just move the negative over. And then I'll show you that in brown. So then you would just do h divided by -1 or something like that. Get rid of this negative. H multiply this by and that gets you negative h sine is equal to y. And then from there you just plug that in as again. Angle for C is 40. H is 50. sine angle 40 equal to your x. Is equal to, put that in later, negative h sine 40 is equal to your y, which is equal to 50 sine 40 is adding the negative 32.1 newtons. And then for cosine 38.3. And then I just realized I forgot to put the x's and stuff here. I'll do that when we move it. I'm gonna go ahead and take a screenshot of this. Because I realized sometimes I get lost with my work because I can't see it all in one place. Okay, so I'm gonna go ahead and erase some of this. Mostly, oh. The vector work. Because we want to keep the values. We're gonna use them right now. I think we get SOHCAHTOA though. We can leave it. Leave for B. Adjacent is x. So that's cosine is x. And then sine as well. There we go. And now we can start doing the vectors. So let me see if I can actually do this all in text. Sorry, the sum. I guess not. Let me try the initial part. We're gonna do them x and y separately. Sigma f of x equal to force a of x. That's what this little notation down here means. So you're looking at the force A and the component of that. And force B of x and etc. I'll write it all out just so that we can see it. And then we'll plug that in later. We're going to do the same thing for the y components. Okay, so then looking at the values that we already determined, force A of x is 17.2 newtons. Force B of x, and that's positive. Force B of x is negative 36.3 newtons. And force C of x, or the vector of x for C is 38.3 newtons. Which add them up to minus 36.3 plus 38.3. That is positive 19.2 newtons. And then we're going to do the same thing for the y. The y component of A is 24.6 newtons. I don't need to write positive, we know it's positive. The force component of B is negative, sorry, the y component of B, negative 16.9 newtons. And then the y component of C is negative 32.1 newtons. So this 24.6. Which equals negative 24.4 newtons. Okay. So we know that these two vectors are what are going to be our vector components for our unknown force, right? Because technically in all of these, we also had the unknown force added in there, and that's why it should equal to 0. So I should probably have drawn those earlier, but let me do that now. Let's remove these. I'll label this as D. So because we know that sigma f of x and sigma f of y and sigma f in general is going to be equal to 0, we know that this is the f of x for D, force D, and f of y for force D. So which is equal to, would probably be, I'm just going to put the little box here because I don't think I can write it. B Those are little blocks. Those are little blocks. And it makes sense that it's going to be opposite to the sum of the other three because we need it to be opposite in order for it to cancel out. Just write the y one. Why not it? Sorry it takes me so long to write this stuff. And again, the y is going to be equal to 0. So then that means I'm going to use a little box because I can actually probably type this out. I'll leave space for it. Negative 19.2 newtons. And F equal to positive 24.2 newtons. So X right. So then we're gonna find the resultant vector using those two. And we're gonna remember our Pythagorean theorem. A squared plus B squared is equal to C squared. In this case, that becomes X squared, I'm gonna leave space, plus Y squared is equal to, I've been using hypotenuse, so I'm gonna keep using H, but H can also be R for resultant vector. Squared, squared. All right, so in order to get rid of that squared on the resulting vector, you're gonna take the square root of the both sides. The square root is gonna get rid of the one on the H, but not on the X squared and Y squared because they're still separate. And also you need to solve. So then it's H of F, H of D, sorry. Square root I'm just leaving room for the square roots, for the squared value, sorry. Plus which equals 30.9 newtons. And then I think that's already past what it asked, because it just asked for the x and y components of this force. But it's also good just to know how to take the resultant vector. And then if you are gonna find the angle that this vector is existing at, then we, over here, we know that it's gonna be in the negative x direction. Negative x direction. And in the positive y something. And then that gives your resultant vector right here. And because this is the x, we're probably going to be doing it off of the x. So then your x is the adjacent. Adjacent. That's supposed to be an arrow. And then your y is your opposite. So then you're going to use tangent for opposite over adjacent. Which is y negative x. And then from there, you're going to take the arctangent and all that good stuff. I've kind of run out of space, so I'm just going to put in our d vector over here, and then that'll be that. Two. Cool. I can take a screenshot. Oh, I guess we can fit in the tangent somewhere. Maybe here. It's 10 to the negative 1. You could also write arctangent, it's the same thing. Do one over here that's tangent to the negative 1 of the oh my gosh, variables. This is y over x. Turns into tangent to the -1 of, oh, I have them over there. 24.2. Over -19. Plug that in. -2 over -2. Actually, I think this negative is going to become a positive because we said that the negative x was under there. But that's going to give you 51 degrees. It's negative. Point. It's about 6 degrees. Right, so then if you were to draw this, you would have it somewhere like about here. I know that's a little big. This is your angle right here because you have positive y right here, and positive negative x over here. Oh, we can put 52 degrees. It's about the same. Are there any questions on this part? I'm gonna go ahead and take that as a no. Okay, a screenshot. I'm gonna clear them. These are 3 problems. I'm not sure if we have time for all of them. I'm not sure if we have time for this one either, because we have like 10 minutes left. Mhm. Total housing units in your location. Oh, I guess we'll have time for this. Remember that both of these have a y value right here and an x value. I should probably draw these a little more. An x value here and a y value up. It's for A. And then we have a y value here and the next value here. The y values are gonna add up to form whatever the total movement of this housing unit is, but these x units need to cancel out. So we'll probably have this as positive x here. And this one as negative x. Right, because if the x's are not equal to each other, then you're gonna have the housing unit move to one direction or another. So that's kind of how you know that they need to be equal. I'll type that somewhere. So then that means that sigma f of x is equal to, these color coded. A of x and f e of x. Fx of, you know what I mean. Okay. So then that means that negative f of a of x it's gonna equal to f b of x. I'll just do them all in one color. We're gonna move this one over to the 0 side. And give us negative f a of x. Equal to b of x. And then we're going to need to look at components to expand on these. We see on both the angle is opposite, so that means x is signed for both. And I'll put force here instead of hypotenuse, so maybe it'll make a little more sense. I think I can type it from here. It's negative f a positive space sine, what is that, 48 degrees? I'll leave it space too. Sine theta to f b sine theta. And then when you plug that in, oh wait, no, you're gonna have to divide. I'll write that part. Okay. I'm just gonna put a line here so you see that it's data. And then we're gonna need to divide this. I should probably do a different symbol for the sign data. I'll do psi. And then because we're solving for f of b, we need to divide by sign psi. Cancels this out. And I'm sure there's some rule that lets you combine the two signs. I've never used it or needed it. I have just divided them both. It's f of b equal to negative of a. I might be able to just type this. Negative f of a, which is 4,500 newtons, times sine 48 degrees. I'll leave space. Divided by sine of 32 degrees. That will equal. Let's go ahead and plug it in. Nice. Negative 66,310. About, it can be about 11 newtons. But let me do the full with some decimals. And then, because we're technically kind of using sig figs, you have two sig figs here. So we're gonna do 63 newtons, 6,300 newtons. I'm sorry. So that's two sig figs. And then that's your answer. And then I guess it asks for the magnitude of FA plus FB. That's finding the Y for both and adding them. I started the recording at, yeah. I have to go, so if you really need me to, I can say 10 minutes more and do that. But Sam, do you want me to? Okay. Um, I'm gonna go ahead and take that as a no. And we can start with that next time. Question 2. Cool. So next time I'll probably go over the quiz if she has a key up. Just because I don't want anyone to like take the quiz having seen my video knowing what it is, and that's not fair to anyone. Okay. Cool. Alrighty, take care. Did you have any questions?
No, Dee, but thank you so much.
Okay, cool.
Have a nice